The first subproblem is about d minus 1. So the objective function will be minimizing d minus 1. Now we will add the related constraints of this variable, which are constraint number 5 and constraint number 6. Also in constraint number 1, we can remove d plus 1 as we wish to proceed just with d minus 1 at this moment and change it to a form of inequality named as 1a. This model has 3 variables, but we already know that the target value for d minus 1 is 0. And I can proceed with this assumption. What I mean that I will assume that d minus 1 equals to 0 and try to find the related feasible region of this situation. Let's assume that f plus n is greater than or equal to 12. And the reason for this is that I have considered d minus 1 as my goal and implemented it in the model. Now I have 3 constraints, 1a, 5, and 6. In 1a, just replace d minus 1 with 0. I can have the feasible region based on these 3 constraints. The next subproblem will be more will provide us with more constraints and make the feasible region become smaller until there is none at all in the force graph. And knowing that we can achieve d minus 1 equal to 0, we will add the related constraint as a hard constraint to the next subproblem and change the objective function to the related priority. And just to have a review of a hard constraint, it is a constraint that must be satisfied by any feasible solution to the model. This is the definition of a hard constraint. Following the same logic, we'll look for the possibility of obtaining 0 as d minus 4 and replace it in the constraint 4, add it to the graph, plot the new feasible region, and what we get is the region satisfying all the constraints of the subproblem and resulting in the value of 0 for d minus 4. The next move is to treat constraint 4 as a hard constraint type in the next subproblem and change the objective function for priority number 3. Considering the goal value of 0 for d plus 2, one more time, the feasible region shrinks because constraint 2 is added to the model. We have more constraints now. We know that this subproblem is feasible and the optimal value for the objective function is 0. And we will add constraint number 2 as 2f plus n less than or equal to 16 to the fourth subproblem and change the objective function again. Adding the related constraint to the graph, we notice that the region is infeasible. And if I consider d plus 3 equal to 0, the model will be infeasible. What can I do now? Simply, I will move toward the feasibility with the cost of accepting some deviation for the last goal. So what I mean that This is the related constraint resulting in D3 equal to the deviation for number 3 equal to 0. I will start moving toward the infeasibility until I touch the feasibility, and I will not move more than this, because I want to minimize the deviation from goals as much as I can. Now I have a point that is feasible and has the least amount of deviation. Priority 1 to 3 have 0 deviation from the goals, but we had to accept a deviation equal to 3.2 for the last one. And the question is, how do we get this value? You already know that. The intersection of constraints number 1 and 2 results in the value of f equal to 4 and n equal to 8. And replacing this in number 3, we will get this result. Now we can add the related hard constraint of minus 0.4 f plus 0.6 n less than or equal to 3.2 to the next subproblem. And in this subproblem, we notice that replacing the values of f and n, constraint 1b is satisfied. Sorry for that. And with d plus 1 equal to 0, I have what I wanted. So although the forced deviation was not 0, I have the last one equal to 0. And the fifth priority goal is met. So that's it. And I hope you have enjoyed this video.